Good afternoon, everyone. Hope you're all doing well. I thought I'd take you through this worksheet just so you would have these problems done for you. You can certainly skip ahead, and I will do my best to do these quickly, but clearly for you. The first question asks, what is the difference quotient? And I mentioned this in class, but it's not a huge emphasis of the course at all. But a difference quotient is any time we have a difference, which is a subtraction problem, and that subtraction problem is being divided. So specifically, we have seen a few different difference quotients. The first one is the ROC difference quotient, where we have f of b minus f of a all f of a all over b minus a. It's trying to find your average rate of change. And the other one that you have seen is this f of a plus h minus f of a all over h. That's also a difference quotient that we've seen. We've seen it in a few different forms. All of these are the limit definition of a derivative. So we've seen this in the context of a limit definition. You should be aware of the limit definition of a derivative. We're going to be using it for a while. The second question asks, how do you find the slope of a curve at a point x is equal to a? What we're going to do is we're going to use this different quotient that we just talked about. We're going to let that h go to 0. So you've seen a few different variations on this. I'm going to write this one as f of a plus h minus f of a all over h. Alternatively, we could think about this as the limit as x approaches a of f of x minus f of a all over x minus a. Notice this is the slope of the tangent line, and the derivative can be interpreted as the slope of the tangent line. That's how we're going to use those two limit definitions. So these are both the limit definitions of a derivative. All right, so we start off with that difference quotient, and then we use the idea, the concept of a limit in order to bring this thing closer. Okay? All right, next question asks, what is a normal line? A normal line is just a line that is perpendicular to the tangent line. It's perpendicular to the tangent line. For those of you who are taking physics, I've mentioned this a few times, but you'll start learning about the normal force. A normal force is just a perpendicular force. So that word normal is just, you can really just think of it as being equivalent to perpendicular, all right? And that symbol, just in case you don't know, that symbol is for the idea of perpendicular. The difference between the average rate of change and the instantaneous rate of change. The average rate of change is the slope of the secant line. And the instantaneous rate of change is the slope of the tangent line. The instantaneous rate of change is our derivative. We're going to start to use these ideas interchangeably. It is the derivative. It's the slope at a single point. It's the slope at a single point. Okay. And so now this worksheet asks you to find some average rate of changes. And obviously they're looking for an opportunity here to test you on your trig as well a little bit. And you may have noticed that I did that on the other worksheet as well. If you're looking for an average rate of change, if you see those words anytime this year, from now until May, you should write on your paper f of b minus f of a all over b minus a. That's what we're going for. And although we prefer the instantaneous rate of change in many ways, please notice that the average rate of change is still useful for us. It isn't a completely useless piece of information. It can tell us a lot about the behavior of a function and what's going on with a function. So we're just going to fill in the pi over 2 and the negative pi over 2 into this function that we're given. And in the denominator, I'll have pi over 2 minus a negative pi over 2. Hopefully you can read this. I know it's a little bit messy. The sine of pi over 2, hopefully you know this stuff by now, and I don't mean to beat a dead horse, but you really do need to know things like the sine of pi over 2. If it's still an issue for you, get back out your unit circle and figure it out. Same with the sine of negative pi over 2. So the sine of pi over 2 is just 1. And the sine of negative pi over 2 is just negative 1. Pi over 2 minus a negative pi over 2, we're going to add those two things together, and in the denominator we're going to end up with pi. So we have 3 minus 1, or 2 over pi. That's our average rate of change. That's the slope of the secant line. If you want to graph 2 plus sine of x, that just looks like the sine of x function, just shifted up by 2. And all this is saying is, so if we think about the sine of x function, it would just be up here, and we would draw it just like this, like this, like this, okay? And what this is saying is that the slope of the line, oops, need to go back in time as well. Okay. And all this is saying is that the slope of this line from here to here, the slope of that line is 2 over pi. That's my average rate of change. That's what that problem is saying. Okay. Next one, same idea, it's just a little bit easier. Again, it's average rate of change. Write down f of b minus f of a all over b minus a. This is 2 squared minus 2, minus 5 squared minus 5, all over 5 minus 2. Our answer there is 6. I'm going to count on you to be able to do the math. Okay? All right, there are only 2 things that you need to know from now until the midterm. And those 2 things are derivatives and average rates of change. I mean, I'm oversimplifying a little bit, but if you don't know what to do on a problem from now until your midterm, most likely you can find the solution simply by taking the derivative and plugging in a value, or by thinking about the average rate of change. Okay, this problem is a little bit drawn out. Okay, I'm gonna do it out the long way, but allow me to do it out the short way first. For those of you who are now feel comfortable with the product rule, if you look at this function f of x equals x to the third, hopefully you're starting to realize right away that that derivative is just 3x squared. So that would mean I can answer all of these questions very quickly, very, very quickly, okay? I'm going to do it out the long way for you in just a second, but I'll do it out the short way right now. If I did it out the short way, my answer to letter B would be f prime of a would equal 3a squared. That's the slope at the point x is equal to a. When does that slope equal 12? I'm just going to set 3a squared equal to 12. That happens when a is equal to plus or minus 2. The equation of the tangent line at to the curve at x is equal to 4. I need 2 things. I need the slope, and I need a point. I'm going to find the slope by simply plugging into my slope equation. This thing is just, this thing right here, that's just a slope equation. That's slopey-dope. That's your slopey equation. You should be able to get that pretty easily now. Our slope at x is equal to 4 is just going to be f prime of 4. And I know I'm a little squeezed up against the edge here, but hopefully you can still read this. My slope is 48. What's going to be the point that I'm dealing with? The point that I'm dealing with is going to be, I'm going to plug into that original equation. I'm going to actually calculate f of 4. It's 4 to the third, or 64. So that point is 4, 64. That allows me to write the equation of the tangent line. The equation of my tangent line is y minus 64 equals 48 times x minus 4. The equation of the normal line, all I have to do for the normal line is just flip my slope over. It's going to be the negative reciprocal, so it's just going to be negative 1 over 48. Sorry about that. Messed up a little there. All right, it's just going to be negative 1 over, 48. Okay? All right, good job. All right, now if I had done this out the long way, let me just show you once. To figure this out the long way, I need to do the limit as h approaches 0 of f of x plus h minus f of x all over h. Now I know some of you are wondering, when do I have to do it out the long way and when can I do it the short way? All I need for you to know how to do is to plug in this first step. This would be x plus h to the third minus x to the third all over h. Now, for many of you, doing something to the third power is a bit of a pain. I get that. All right, this is a bit of a pain. But when I do this to the third power, here's what happens. Let me just show you. This becomes x to the third plus 3x squared h plus 3xh squared plus h to the third minus x to the third all over h. The x to the thirds will cancel out. I can divide out an h. And my answer here, once I plug in the 0, is just 3x squared. Notice I get the same answer. That's my slope equation. Do you see it here? Here it is, 3a squared. It's also over here at 3x squared. Okay? I know that that was quick. Practice it. Make sure that you can do that. If you're wondering how much you would have to be able to write down, I just need you to be able to recognize that this is a slope equation, that is the derivative equation. That's what I'm more interested in at the end of the day. Let's do the second page. Find the average rate of change of this function, f of x equals the square root of x from 4 to 9. If I see the words average rate of change, I write down f of b minus f of a all over b minus a. I'm going to do f of 9 minus f of 4 all over 9 minus 4. Now I be in business. This is 3 minus 2 all over 5, which is just 1/5. Okay. Find the instantaneous rate of change at x is equal to 9. Finding the instantaneous rate of change is a different question. I'll do it out the long way and then talk about it the short way. I'll do it quickly. The limit as h approaches 0 of the square root of, I'll do a plus h. We could have done x plus h. That would have been fine too, all over h. In order to solve this, we're going to have to rationalize here. You can quickly see this is becoming a bit of a pain in the neck. I'm not having fun. But I can solve this fairly easily. This is the limit as h approaches 0 of a plus h. This becomes minus a all over h times the square root of a plus h plus the square root of a. Again, I know I'm doing this fast, but you have the benefit of stopping the YouTube channel. This becomes the limit as h approaches 0 of h over h times the square root of a plus h plus the square root of a. And my answer here just becomes 1 over 2 root a. I'm looking at x is equal to 9. That means my slope is equal to 1 over 2 root 9 or 1 over 6. Doing this the faster way, notice that the square root of x is the same as x to the 1/2. So taking the derivative of that, the power rule would be 1/2 x to the negative 1/2. So I brought the 1/2 down to the front, subtracted 1 from the 1/2. This is 1 over 2 root x. Notice I get the same stinking answer. It's just written in a slightly different form here, but it's the same answer. Equation of the tangent line. What else do we need? We also need the point. So the equation of the tangent line, f of 9 is equal to 3. That's our point. So we have y minus 3 is equal to 1/6 times x minus 9. Equation of the normal line, simply flip this thing over. I have 1 minute left before my free YouTube thing runs out. This thing is asking an object is dropped from the top of a 150-foot tower. Its height above the ground after t seconds is given by this function. This is a height. This is a position. All right, that's a position function. That is giving position. This is asking how fast something is going. If we start off with position, we're asking about speed or velocity. What are we going to do? We're going to take its derivative. So s prime, the derivative of position, will equal the velocity. And my velocity here is negative 9.8 t. I'm looking specifically at how fast its object is falling out after 2 seconds. That's going to be negative 19.6 meters per second. Notice we went from meters The S is given in meters, and then we went to meters per